How do we interpret the standard deviation? 50% of the scores in the distributions must lie below the mean. 34% must lie between the means and one standard deviation. How do we interpret the standard deviation? 50% of the scores in the distributions must lie below the means. 34% must lie between the means and plus one standard deviation. Therefore, 84% means 50% plus 34% of the scores in the distributions must be below 1. Therefore, 84% mean 50% plus 34% of the scores in the distributions must be below Therefore, 84% mean 50% plus 34% of the scores in the distribution must be below plus one standard deviation. How do we interpret the standard deviation? 50% of the scores How do we interpret the standard deviation? 50% of the scores in the distributions must lie below the mean. 34% must lie the mean. How do we interpret the standard deviation? 50% of the scores in the distributions must lie below the means. 34% must lie between the means and plus one standard deviation. Therefore, 80% means 50% plus 34% of the scores in the distribution must be low. Therefore, 80% means 50% plus 34% of the scores in the distribution must be below plus one standard deviation. Here is example the differences within standard deviations. The standard deviation shows the boys This is the comparison of standard deviations. This is the comparison of the standard deviation values. This standard deviation for boys and men baseball team. In the boys baseball team, standard deviation equal 5.25. Here is the comparison of standard deviation values. This example shows the standard deviation for boys and men baseball teams. In boys baseball team, standard deviation equals 5.25, while the men's baseball team standard deviation equals 2.45. The men's baseball team standard deviation is small value, and the boys baseball team standard deviation is high value. So the higher standard deviation, the various highs among the teams. In other words, the smaller standard deviation, the differences among the groups is very close or clusters. In general shape of test In general shapes of test score distribution, a test score distribution reflects one of the commonly observed shapes. It can be systematical, skews, unimodals, bimodals, or multimodals. Here is the general shape of test score distributions. A test score distribution reflects one of the common observed shapes. It can be systematic. Here is the general shape of test score distributions. A test score distribution reflects one of the commonly observed shapes. In general shape of test score distributions, a test score distribution reflects one of the commonly observed shapes. It can be systematical, skewed, unimodals, bimodals, or multimodals. We use this shape to observe how the performance of the student in the group. In normal distribution is a bell shape, show that the performance fall around the mean. For rectangular distribution, the test score vary spread among the teams. Normal distributions The test score in normal distribution present as a bell-shaped curve. It means that the score fall around the means. And the scores the test score in normal distributions is the bell-shaped curve. The test score in normal distribution fall in bell-shaped curve. Test scores in normal distribution fall in the bell-shaped curve. This means that the score fall around the mean and the student performance is very clustered. The test scores in rectangular distributions mean that the scores or the student performance spread away from the means or in various or heterogeneous. While the test score fall in a U-shaped curve, it means that while the test score fall in the U-shaped curve, it means that the performance. While the test score fall in the U-shaped curve, it means that the student performance are very separated. While the test score in the U-shaped curve means that the performance of the student can be distinctive. while the test score fall in the U-shaped curve. Vậy rồi. Thế banyak perkara Pak ni. Tok kom dia sampai macam ni. While the test score fall in the U-shaped curve, it means that the performance very clear distinctive, or we can say the performance of the student can be separated into two categories. When the test score fall in the U-shaped curve, it shows us that the performance is clearly distinctive, or we can say the student performance can be defined when the test score fall in the U-shaped curve. It means that when the test score fall into the U-shaped curve, it shows us that the performance of the student are separated into two distinctive. While the test score fall into the U-shaped curve, it shows us that the performance is clearly separated, or we can say that the group of the student could be separated or divided into two different groups. One group fall below the mean and the other group fall higher than the mean. While the test score fall into the U-shaped curve, it shows us that the performance of the student is separated into two different groups. One group fall below the mean and the other group scores higher than the mean. The systematicals. The normal distribution or the ball-shaped curve. Most scores are near the centers. The low and the highest end of score scales contain very small difference. In systematicals, the normal shape distribution or the ball-shaped curve, most scores in systematicals, the systematical, the normal distributions or the bell-shaped curve, it means that most scores are near the centers. The low and the highest end of score scales contain very small frequencies of scores. The U-shaped distributions means a large number of scores occur at the lowest and the highest end. In the U-shaped scales, in the U-shaped distributions means a large number of scores occur at the lows and the highs occur at the ends, but none or few occurs in the middle of distributions. The rectangular distribution means an equal number of students receive each score. It's very spread beyond the means. School. In school, it can present either negative or positive score. Negative scores, it means that mastery score. The score, a the score can be divided into either negative or positive score. The negative score or a mastery curve mean most scores occur at the highest ends of the scale, indicating that more students receive higher scores than lower scores. The positive scores mean most scores appear toward the lower end of the score scales, indicating that the test was difficult for most of the class. Unimodals, or we can say only one score appear most frequently. Bimodals, it means that two scores, some distant from each other on the scale, have high frequencies than the scores surrounding them. Multimodals means more than two scores have. Multimodals is more than one score. Multimodals means more than two scores have a typically high frequencies compared to the scores around them. What are the differences between p-values and statistical significance? What difference between the p-values and statistically what the difference between p-value and statistically what is the difference between p-values and statistical significance? What is the difference between the p-values and statistically significant? What is the difference between the what is the difference between p-values and statistical significance? What exactly is a p-value? The p-values or probability values tells you how likely it is that your data could have occurred under the null hypothesis. It does this by calculating the likelihood of your test statistic, which is the number of calculated by a statistical test using your data. This p-values and statistical significance. What is the difference between p-value and statistical significance? What exactly is a p-value? The p-values or probability values tells you how likely it is that your data could have occurred under the null hypothesis. It does this by calculating the likelihood of your data. It does this What is the difference between what is difference between what is difference between p-value and statistical what is difference what is difference between p-values and statistical significance? What exactly is a p-value? The p-values or probability values tell you how likely it is that your data could have occurred under the null hypothesis. It does this by calculating the likelihood of your test statistics, which is the number calculated by a statistical test using your data. P-values are most often used by researchers to say whether a certain patterns they have P-values are most often used by researchers to say whether a certain patterns they have used P-values are most often used by researchers to say whether a certain pattern they have measured is statistically significant. P-values are most often used by the researcher to say whether a certain pattern they have measured is statistically. P-values are most often used by researchers to say whether a certain pattern they have measured is statistically P-values are most often P-values are most often used by researchers to say whether a certain pattern they have measured is statistical. P-values are often used by researchers to say whether a certain pattern they have used P-values are most often used by researchers to say whether a certain pattern they have measured is statistically significant. Statistical significance is another way of saying that the p-value of a statistical test is small enough to reject the null hypothesis of the test. Statistical significance is another way of saying that the p-value of a statistical test is small enough to reject the null hypothesis of the test. In this part, we should know how small is small enough. The most common threshold is p lower than 0.05. How do we know how can we say, how can we know the small is small enough? The most common threshold is p lower than 0.05. That is, when you could expect to find a test statistic as extreme as the one calculated by your test only 5% of the times. But the threshold depends on your field of study. Some fields prefer threshold of 0.01 or even 0.001. For example, reporting the result in your comparison of a cat diet A and a cat diet B, we found that the lifespan on diet A mean equals 2.1 years old and standard deviation equals 0.12. For example, reporting the result in your comparison of cat diet A and cat diet B, we found that the lifespan on diet A, the mean equal 2.1 years and standard deviation equals 0.12, were significantly shorter than the lifespan on diet B, mean equal 2.6 years, standard deviation equal 0.1, with an average difference of 6 months. T 80 equals minus 12.75 and P lower than 0.10. We found that the span life on diet A mean equal 2.1 years. For example, reporting the result in your comparison of cat diet A and cat diet B, we found that the lifespans on diet A mean equal 2.1 years, standard deviation equal 0.12, were significantly shorter than the lifespan on diet B, mean equal 2.6 years, standard deviation equals 0.1, with an average difference of 6 months. T 80% equals minus 12.70, while the P lower than 0.01. You can understand about the p-value from this video. These videos give you information about how to interpret the p-values. This video gives you more information about how do we use p-value or how do we interpret the p-value.
Hey everyone, so today I will be talking about p-value and what does it represent in statistics. Statistics is everywhere. If you see this touchpad carefully, what you see is a normal bell-shaped curve. Let's say p-value in this region is 0.01. This means I touch over here 1 in 100 times. Let's say the p-value in this region is 0.8. This means 80 out of 100 times I'm gonna touch in this region. Now if we see the statistical definition of p-value, Then, p-value is the probability value for the null hypothesis to be true. To understand p-value, first we should try to understand null hypothesis. The null hypothesis is the hypothesis which treats everything same, everything equal. Let's take an example where plants are treated with fertilizer A and fertilizer B. The null hypothesis here will be there's no difference in the effect of fertilizer A and fertilizer B. Now, there are many statistical tests, say for example, t-test, f-test, ANOVA, etc. And the final result of each test is judged on the basis of the p-value obtained. The p-value can take any values from 0 to 1. Let's say p-value is 0.1. This means if I repeat an experiment 100 times, 10 out of 100 times the null hypothesis will be true. Let's say p-value is 0.3. This means if I repeat the experiment 100 times, 30 out of 100 times the null hypothesis is gonna be true. Let's say p-value is 0.05. This means if I repeat the experiment 100 times, only 5 times the null hypothesis is gonna be true. Okay, let's take an example of t-test. The t-test is used for the comparison of mean. Let's consider the previous experiment where the plants were given fertilizer A and fertilizer B. Let's say a graph represents the mean and the standard deviation in the height of the plant. Now the t-test is going to compare the two means. Let's say the p-value for this test is 0.03. This means if I repeat this experiment 100 times, only 3 out of 100, the null hypothesis is going to be true. Now the next question that arises over here is, should we consider this significant or not? Taking a decision based on p-value is completely in the hands of the experimenter or the scientist who is doing the experiment. The researcher decides the level of significance for his experiment. Let's say the level of significance decided by the researcher was 0.05. Then in this case, the researcher have to reject the null hypothesis. Conclude that there is a significant difference between fertilizer A and fertilizer B. Now let's say the level of significance decided by the researcher was 0.01. Then in this case, the researcher have to accept the null hypothesis and conclude that there is no significant difference between fertilizer A and fertilizer B. So to summarize, the researcher first decides the level of significance, then he does the experiment and finds the p-value. If the p-value is more than level of significance, then the null hypothesis is accepted. And if the p-value is less than level of significance, then the null hypothesis is rejected.
You have just understand now you have learned that how to use p-value to show accepted result or rejected result. In this task, you are asked to study the following activities. You have just learned how the p-value is accepted or rejected. In these activities, you are asked to demonstrate your understanding in these activities, you are to perform some activity. In these activities, you are to do some tasks to demonstrate your understanding of the this activity. You are asked to perform some tasks to demonstrate your understanding these lessons. The following outline summarizes the procedure used to describe and evaluate group performance tests. 1. You have this activity. You ask to perform a certain This activity, you ask to perform some tasks to demonstrate your understanding these lessons. The following outline summarize the procedures used to describe and evaluate group test performance. A. You have to describe and compare the test results. 1. Create a frequency table or frequency polygons of the test scores. 2. Compare the location of the highest and the lowest earned scores with the highest possible score and decide whether they are reasonable given the complexity of the task measured by the test and achievement characteristic of the group. 3. Calculate and compare measure of central tendencies. A. Calculate the mean and note its position in the score distribution. B. Locate the median and note its position in the score distribution. C. Locate any modes or modes and note its position in the score distribution. D. Compare the mean, median, and mode and describe the distribution as being systematical or skewed based on these measurements. D. Compare the mean, median, and mode and describe the distribution as being systematical or skewed based on these measures. 4. Compare the observed measure of central tendencies and their locations in the score distribution to those you would expect, given the complexity of the task and the achievement characteristic of the group. 5. Calculate and compare the measure of reliability. 5. Calculate and compare the measure of variabilities. A. Calculate the range. B. Calculate the standard deviation. 6. Compare the variability measure with those you would expect, given the complexity of the task and the group characteristics. 5. Calculate and compare the measure of variabilities. A. Calculate the range. B. Calculate the standard deviation. 6. Compare the variabilities measures with those you would expect, given the complexity of the task and the group characteristics. A. Note any discrepancies between the measure you expect and those you would observe. A. Note any discrepancies between the measures you expected and those you observe. B. Try to explain any discrepancies you find. Discrepancies are usually caused by misjudging the quality of instruction or the test. They are also potentially related. They are also potentially related to misinterpreting the complexity of the task or the group achievement. B. Try to explain any discrepancy you find. B. Try to explain any discrepancy you find. Discrepancies are usually caused by misjudging the quality of instruction or the test. They are also potentially related to the misinterpreting B. Try to explain any discrepancy you find. Discrepancies are usually caused by misjudging the quality of instruction or the test. They are also potentially related to misinterpreting B. Try to explain any discrepancy you find. Discrepancy. B. Try to explain any discrepancy you find. Discrepancies. B. Try to explain any discrepancies. B. Try to explain any discrepancies. B. Try to explain any discrepancies you find. Discrepancies are usually caused by misjudging the quality of instruction or the test. They are also potentially related to misinterpreting the complexity of the task or the group character. Try to explain any discrepancy. B. Try to explain any discrepancies. B. Try to explain any discrepancies you find. B. Try to explain any discrepancy. D. B. Try to explain any discrepancies you find. Discrepancies are usually caused by misjudging the quality of instruction or the test. They are also potentially related to misinterpreting the complexity of the task or the group correct. B. Try to explain any discrepancies you find. Discrepancies are usually caused by misjudging the quality of instruction or the test. They are also potential B. Try to explain any discrepancy you find. Discrepancies are usually caused by misjudging the quality of instruction or the test. They are also potentially related to misinterpreting the complexity of the task or the group achievement characteristics. C. Check the group performance as being better than expected, as expected, or lower than expected. Thank you for participating in this presentation.